This video deals with definitions and few results on elementary number theory. Now, what is number theory? It is a branch of pure mathematics. And German mathematician Gauss once said that mathematics is the queen of all sciences and number theory is the queen of mathematics. Number theory mainly deals with the properties of integers and in particular prime numbers. Now, what are prime numbers? A prime number is a number whose only divisors are plus or minus 1 and plus or minus p. P, Q, R are the letters that are used to denote prime numbers. We have few examples. We know that 2 is the only even prime and 3, 5, 7, etc. They are all simple prime numbers. And n square plus 1 for smaller values of n also gives prime numbers. And n square plus n plus 41 if n is less than 40. N square plus n plus 17 if n is less than 16. 2n square plus 29 if n is less than 29. N square minus 79n plus 1601 if n is less than 80. And the last one is 2 power n plus 1 if n is less than 5. Now we have this definition. When do we say that a number a divides another number b? So if a is a number which is a non-zero number, it is said to divide a number b, and we denote it as this way a. We have to put it in as a straight line b. A divides b if b is integer times a. That is, b is equal to ma, where m is an integer. Now, for example, we know that 2 divides 6, and this is how it is written, and this is nothing but the 6 is nothing but 3 times 2. So similarly, 3 divides 6, and 6 is written as 2 times 3. So a is said to divide b. This is the way that we write that a divides b, which means that b equals ma. And this being definition, it holds in both ways, meaning that whenever you see that b is integer times a, it implies that a divides b. Now, when do we say that some number is a divisor of some other number? See here, if a divides b, then a is called a divisor of b. So whatever here you have, that is called divisor of b. Now 2 and 3, from here we see that 2 and 3, both of them divide 6. So 2 and 3 are divisors of 6. Now we have this result which will be used later. If a divides b and a divides c, then a divides b minus c. A divides b and the same a divides c, another number. Then this a will divide the difference of these two. In fact, the sum difference, both we have, but here later we need this part, so we are writing that. Now we are given that a divides b, which means that b is integer times a, and similarly a divides c means c is integer times a. Now if we subtract c from b, that is this one, that gives b minus c is equal to ma minus na. So taking that m minus n out, a is common, that is taken out. So we have m minus n into a. M is an integer, n is an integer. The difference is also an integer. So we have that to be k times a, which means that b minus c is integer times a. So as per this definition, what we should have is a divides b minus c. So that is our result. Next we have the definition of composite number. Now we say that n to be a composite number whenever n is written as a into b, where a and b are both not equal to 1. They are they are divisors of n. That is, If we have either A or B to be 1, say, then in that case n will become a prime number. So whenever any number is written in this way, it is called a composite number. 6 is a composite number because 6 is written as 2 into 3 or 3 into 2. Usually in ascending order we write, where 2 and 3 are prime numbers. That we will see in the next video. Next we have the greatest common divisor. Even this concept will be used repeatedly. A positive integer c is said to be the greatest common divisor of a and b. You are given two integers a and b, and you want to say some other integer to be the GCD of a and b, when it can be said as the GCD of a and b. So if first of all c divides both a and b, it should be common divisor. It should divide first, so divisor, and it should be common, which means c should divide a and c should divide b also. And we want to have this c to be the greatest. So that means if we have any other divisor of a and b, that is, if d divides a, d divides b, then d must divide c. That is, this is the greatest common divisor. Now we consider, this is the notation used. C is equal to this, it looks like ordered pair, but you cannot equate an ordered pair to be to a number. So you can equate only an ordered pair to another ordered pair, but here this one should be read as C is the GCD of A and B. Now we have these two examples. Suppose we consider 6 and 10. We say that 2 to be the GCD. Why is it so? We'll first list out the divisors of 6 and divisors of 10. Then what is common to them? We have 2 to be common to them, and that is the only, 1 also is common to them, and 2 is also a divisor which is common to both 6 and 10. But we want to have the greatest one, so we have 2 to be the GCD. And similarly, if you consider 12 and 28, say, then 1 divides 12, 2 divides 3 divides 12, 4 divides 12, 6 divides 12, 12 divides 12, and in the same way 1, 2, 4, 7, 14, 28, they are all divisors of 28. So we have 1 to be a common divisor, 2 to be a common divisor, 4 to be a common divisor. So among these three, we have 4 to be the greatest common divisor. So we have GCD of this and this to be 4. But if the numbers are too large, then this method cannot be used, for which Euclidean algorithm is to be used. So that is not as such dealt here. Now next we have this concept, relatively prime numbers. When do we say that two numbers are relatively prime? When the GCD is 1. So if the GCD of, we given any two numbers, we know that the GCD is given by this. And if the greatest common divisor happens to be 1, say, in some cases we will have the GCD to be just 1. So in that case we say that A and B are relatively prime. So this is an example. If you consider 12 and 19, then you don't have any number to be common to them other than 1, common divisors. And similarly, if you consider this, 1 is the only common divisor. So two numbers are said to be relatively prime if the GCD is 1. So in the next video we will see that decomposition of a composite number, namely the fundamental theorem on arithmetic and sum of divisors and number of divisors of n. What is the formula for this, and how any number n can be decomposed as product of prime powers. So that can be seen in the next video.